Welcome to the Deep Dive, the show that takes complex topics and transforms them into clear, actionable knowledge. Today, we're diving deep into the intricate world of gas turbine fuel systems and the revolutionary FADC controls. This isn't just about understanding engine parts, it's about grasping the very brain behind the modern jet engine. Okay, let's unpack this for you. We know you're deep in your ATPL theory exams prep, and systems like these are absolutely critical. Our mission today is to cut through the jargon, distill the essential concepts, and give you those aha moments that will not only help you ace those questions, but genuinely understand the engineering marvels you'll soon be flying. We've got a fantastic deep dive into gas turbine fuel systems and FAD controls, a real treasure trove of information designed to equip you with the essential knowledge needed to respond confidently to those tricky ATPL theory questions.
Absolutely. And what's truly fascinating here is how these systems, often unseen beneath the cowling, are absolutely fundamental to the safe and efficient operation of jet engines. For any aspiring pilot, this isn't just theoretical, it's foundational. ATPL exams often test beyond just what a component does. They really challenge your understanding of why it's there, how it integrates, and its operational nuances. So this deep dive will provide both that foundational component knowledge and the critical understanding of how modern electronic controls tie it all together, which is undeniably vital for your success.
Okay, let's embark on a journey then. Let's trace the fuel's path from the moment it leaves the aircraft's tanks all the way to the burners in the combustion chamber. It's a precisely choreographed dance of components, each with a vital role. Think of it as the engine's incredibly sophisticated digestive system, meticulously regulated for consistent, reliable performance. So we're starting right at the beginning, the initial transfer from the aircraft itself. Before it even reaches the engine's dedicated system, what critical steps are happening to get that fuel moving?
Right? The very first step for the fuel system within the aircraft begins naturally in the main fuel tanks. Here, you have booster pumps. These are critical because their primary role is to ensure a continuous and pressurized flow of fuel from the tanks towards the engine. They overcome potential suction issues, especially at altitude, and, ensure a steady, positive supply. From these booster pumps, the fuel immediately passes through a series of non-return valves. As the name implies, these are essential for directing the flow strictly in one direction, preventing any backflow that could disrupt the system, maybe introduce air or create instability.
So a one-way street, basically, keeping everything moving in the right direction. And then we encounter what sounds like a crucial safety point, the engine fuel shutoff.
Exactly. Immediately after the non-return valves, we find the engine fuel shutoff valve. It's often called the pylon shutoff valve because of its typical location near the pylon connecting the engine to the wing. Now, this valve serves a couple of absolutely crucial roles. Its primary purpose is for maintenance. It allows for the safe isolation of fuel to the engine when, component removal or maintenance is being carried out. But significantly, it also has a secondary emergency function. It can be closed from the cockpit by pulling the fire handle.
Ah, the fire handle, okay.
Yeah, if you get an engine fire warning, pulling that handle isolates the fuel from the engine, cutting off the supply to potentially starve the fire. This is a critical safety feature, obviously. Now, here's a key point for your ATPL exams. Pay attention to this bit. While this valve can be used in an emergency to stop the engine, it's not the fastest method for shutdown.
Oh, really? Why is that?
Well, the engine will take a considerably longer time to run down compared to other shutdown procedures that act directly on, say, the fuel control unit. So understanding its dual roles, primary for maintenance, secondary for emergency isolation, and this operational characteristic of a longer rundown time, that's vital for those questions. Remember that distinction.
Okay, the fuel has successfully transferred from the airframe and made its way to the engine. What's the very first major stop within the engine's own system, and what's its job?
Right. Once the fuel enters the engine's dedicated system, its first major component is the low-pressure pump, or LP pump. It's sometimes referred to as the backing pump. This pump is driven directly by the engine's accessory gearbox, meaning its speed is proportional to the engine's operation. Its function is pretty straightforward.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.